Thank you so much. So, I thought why I'm here, and I thought about what might be your questions. And your question might be, well, what the heck is OPC UA? Obviously, what is OPC Foundation, but what is he offering us? But I also have one wish later on, why I am here. I also have a wish to you. That's my goal. First of all, let's talk about what is OPC UA and what is the OPC Foundation. Let's start with one slide on the organization. What is the OPC Foundation? It's a non-profit organization, and we are definitely super international. The headquarters and the legal entity is located in North America for historical reasons. The initiative started there. Headquarters in Scottsdale, Arizona, Phoenix, Arizona. I'm located in Germany, which you might realize on my accent. The director of compliance is also in USA. Other people are in Asia. The lab is in Europe. So we are really around the globe. And it's a mission that we want to exchange information in a secure way, scaling from small sensor, the field, the assets, which you can physically touch, scaling up to IT applications, cloud data spaces, metaverse, in a way that it's completely independent from any market, from any vendor. And it should allow horizontal communication and vertical communication. The delivery, what we have, OPC UA, is an IEC standard, which is critically important. You will see that later on, that other associations can trust on this. And everything what we do is open. Open source. So first of all specifications we do are open once they are released. And open means available without any fee. You can just download them. You have to register for export regulation, but there's no fee. All tools, all software is available as open source on GitHub. For certification, the OPC lab to check the quality of your services is open, also for non-paying members. You don't have to become a paying member of the OPC Foundation. That's my message here. And what we are really proud on, it's a super large ecosystem with education, with toolkits to give you a ramp start. But we are also super proud to have modern IPR policy. I am an engineer, started as an electrical engineer and was 10 years a developer and then 10 years product managers. And honestly, in these days, and at that old days, I didn't take care much on the legal frameworks. Running an association, I know that standardization can only be done in the point of legal and technology and business. So legal is important. And what we are proud on is that all 950 plus members signed the agreement that nobody is suing somebody else in a specific way. Everybody is treating everybody identical. This is not what all associations have. So it's a kind of suing patent protection umbrella that this technology can grow into the world. The reason for this is that who is the member? It is all big OT companies of the world. The Siemens, the ABBs, the Emersons, Rockwells, Phoenix, Beckhoffs, Vagos, whoever in the world, but also big IT companies. AWS is a sponsor here. Is a member, like Google, like IBM, like Microsoft Azure, like SAP. Now think about all these patents in a pool and they are blocking each other, and so we have peace in the world. Really, really important. As you see, we have over 960 members in the world. About 60% are from Europe. Even the initiative has started in US. And at the beginning, Siemens was the only founding member from Europe. They have been on the board of directors from the beginning. Today, the situation has switched completely because of the huge investment in Europe on digitalization efforts, like why you are here, right? There's so much behind on power, funding, manpower, and this has been realized also on the board of directors. Now half of the board of directors are European companies, elected in a democratic way. We are not, you can't buy in by putting money on a table. You are elected by members. Okay, what is the aim? OPC UA has exactly the, and oh, by the way, OPC UA is not a protocol. If you thought about, oh, yeah, OPC is something like Modbus, should I select MQTT or Modbus, or please clean up your brain for a second and let me give you the better answer. OPC UA is not a protocol, or let's say it's much, much, much more. What we want to do is we want to get rid of the old communication pyramid where you always have to transfer your data from one model to the other model and then select a different protocol to transfer it level by level up and information are bubbling up. This is so inefficient, it's not fun. It's just efforts without any benefits. What we want to have is a mechanism, an ecosystem where you can bypass layers. It's just like the USB connector, which fits into everything, every computer from every vendor, and you can share information and bypass layers. The sensor can directly push data into cloud, to data spaces, without first pushing them to SCADA, MAS, and whatever. So OPC UA has defined the payload on protocols, and we can move them over different transport layers, as you see here. It includes also file transfer and REST interface, which is important for you as an IT community here. So in a super condensed way, what is OPC UA? It's an infrastructure, it provides semantic interoperability. It's a framework which has overall 3 parts. It has a super rich modeling language. It has a lot of built-in transport capabilities, including file, not only online data, also file, offline data, also REST interface. And it has built-in security for both, for the transport layer and accessing the information. And this is why you can do horizontal communication, vertical communication between OT, the factories and clouds, and within cloud applications or data spaces or metaverses or whatever, digital twins. And this is exactly what I'm talking a little bit more in detail, that you really get a feeling on what's going on. I realized when I was sitting in row 6 yesterday that I couldn't read it, so I'm aware that you can't read it. You can download the slides, but I will talk a little bit about this. As mentioned before, OPC UA is completely independent. It is not owned by one big vendor. It is cross-platform, across multiple vendors, and completely independent from any domain. But we started in discrete manufacturing, in process automation, and energy. This is where our home ground is, but we meanwhile also have grown out of this. You will see that later on. As mentioned, OPC UA is an international IEC specification. Everything is international, everything is elected democratically. And the technology is scalable. It goes down into smallest sensors. The smallest footprint is about 15 kilobyte, including the TCP stack. Of course, you don't have the big all features then, obviously not. It just provides you that you can connect, that you can browse a few variables, and you can read and write them. And all the other fancy stuff is not included, obviously not. So it's scalable, and it's addressing machine-to-machine communication, horizontal. It is addressing machine-to IT, to services. We say cloud, but in general we mean applications, and we don't care are they on edge or in cloud. And obviously you can talk between applications, so between compute and compute power. And built in is different transport mechanisms. And you need different transport mechanisms because there is not the one and only protocol fitting to all. In your world, maybe MQTT is the best choice, and you know REST interfaces, but with that technologies, you can't run machines and a robot because it's not deterministic, it doesn't provide other functionalities via these transport mechanisms. So there is not the one and only protocol to trust on and believe the world is becoming easier. And that's why we defined the payload, and we can move that payload over different protocols. And this is, I'm jumping to the transport. No, I should first talk about modeling, obviously. Transport is a second part because I believe it's less important. Whatever protocol will come in future and more smart students will design something else which is more efficient, welcome. If it becomes industry relevant standard, we are able to integrate that. But it is definitely that modeling is to describe what is my asset, my device doing. And then we have transport, robustness, security is built in. We have a security team taking care weekly on what has happened, what's going on. So overall, the ecosystem is we provide the framework, and others with partners, we do the 100 companion specifications. And to give you an idea what this means, and they do also education hackathons that within 2-3 days you get your device up and running, providing that specific information model. I'm a pump, I'm a robot. I'm an injection molding machine, I'm a motor. And obviously this is too small, you can't read that, but all the information are public available. You can download the specs, you can download the information model. It is for human readable version, a PDF, and it's a machine readable version at the end, XML schema, that you can download that and integrate that into your services. So what we are proud on is that we are growing also in other areas, like industrial kitchen equipment. You can also buy that from vendors. I'm a little bit confused on the time because the time started at 13 minutes, and obviously it should start at 0. So we are extending right now into the world of the energy world. We are doing a lot of efforts to grow into this. Not we as an organization, it's driven by industry partners. The industry like Equinor, they are driving this. The organization, the OPC Foundation, is receiving 0 research money. We are just driven by industry to fulfill industry needs. So there's a lot of power behind. All these collaborations we have around the world, this is key because we know we can't solve everything in the world. We need building blocks coming together. For example, we don't care on governance. This is not on our radar. This is where we are not experts. Other people know this much better, and you in the audience know this much better. But we do of information models, and this is where we spent a lot of money, that the robot team and the injection molding team do not define different energy management interfaces and models. Okay, where I'm really proud on is that together with all the OT companies, and you see just a few logos here, I have to update that slide, meanwhile it's over 50, they have agreed to have one single transport mechanism from the OT world to the IT world to cloud. Because we all know, hopefully, that MQTT is not enough. MQTT is just a payload agnostic transport, but who is defining the payload, that you have an easy out-of-the-box understanding? And this is what the OPC Foundation designed and published in the year February 2018, and we are proud that all big automation cloud suppliers, AWS, Google, IBM, Siemens MindSphere, SAP, Microsoft Azure, have agreed to support this. And Microsoft Azure, AWS, are already supporting this. SAP and now Siemens MindSphere also, and SAP announced it to deliver in February 2024. And this means that if you send a message, a variable status from the Siemens Beckhoff Phoenix PLC, temperature 1 has a value of 42 degrees. The payload is identical on the wire via MQTT, and nobody needs any formatting routines to understand the message. And what we deliver over MQTT is both JSON and binary. I don't want to go into the details. Both mechanisms make sense. So we harmonize this, and this is critically important to understand information. And I believe this is where you also can benefit a lot for data spaces. Because how do you get information from data into data spaces? You are keen to get information which are standardized, that you automatically understand them and know them. It helps you for artificial intelligence. You don't need a learning curve for 3 months and then analyze the data. No, you know automatically what the data mean. So you have a lot of benefits here. OPC UA is already, we made demonstrators for the metaverse. So this is a demonstrator which we have been shown last year. Again, driven by industry, big companies, Microsoft, Siemens, and Schneider, and others are behind and have shown this public. There are other associations like the Digital Twin Consortia in the United States, which are using OPC UA to describe a digital twin. Again, remember, OPC UA has rich modeling capabilities, languages, and so they are using this, and then they can exchange information to other digital twins via REST and via MQTT, with the MQTT. Okay, 2 minutes at the end. Offerings. OPC UA is a super language with a lot of functionalities and tools, including deterministic transfer, including functional safety, a lot of different transport mechanisms. And then you say, oh wow, it's so rich, that's too much for me. I don't need that. Obviously, it's like where sometimes you want to have big functionalities, and sometimes you say, no, I'm just selecting in my cloud application, for example. Obviously, you don't select any TCP or UDP communication, but you are using REST and MQTT. But I tell you, for the lowest robot, REST and MQTT maybe not the best for the OT world. Data exactly require OPC UA over MQTT and file transfer. We provide REST interfaces with file transfer out of the box, easy. So you can collect the life cycle of a product. You don't need other solutions for that. Okay. Where do I have to stay to? So the offerings, to make you aware, everything is open source. You can download this one. We have a starter kit based on a Raspberry Pi, which you can have a RAM then 1 hour. We have an academic program, free of charge, where you have learnings in 6 different languages: Spain, Italy, Chinese, France, English, obviously, Korean also. These are the key countries where we are, languages where we are on the road. And it has been recorded by a professor to explain the content. You can steal the content and run it. There are success stories and a podcast, and I highly encourage. Again, this is a standard which is 17 years in the industry without any compatibility break. And this is important for the industry. You can trust this technology, providing super modern modeling languages. You do something, and then you have automatically connection to all big IT cloud providers. And my hope is, and this is why I'm here, I want to collaborate with you. I want to get in touch with you. Because we are the enabler that you get easily data in your data spaces, standardized, including security. That's why I'm here. So please talk to me. Thank you so much for your audience.
Thank you very much. I don't think there is a space for questions, but thank you, Stefan. We had you with us last year. I was impressed. And really, this is going well. And definitely we need to engage more for working on data spaces and also on all the different topics on artificial intelligence. We will be in touch, and please talk to Stefan.